Okay, hi everyone. We are live with Osprey expert Dr. Paul Spitzer. He will be chatting with us concerning the hatch watch and the Osprey eggs about to hatch. I will let him introduce himself. I'm Rick with Audubon and Explore.org, and I'll be asking questions to Paul for this audio-only chat today. Thank you, Paul. Will you tell us a little bit about yourself?
Yeah, Rick, thank you. It's been my privilege to study ospreys ever since I was quite young, beginning in 1968, so that's spanning more than 45 years now. And I got my start because of DDT. The questions of how DDT affected birds and what its effects in general were completely unresolved, and a whole group of us from the 60s through the early 70s had the privilege of doing those studies. We focused on the eggs, and it was learned that the eggs were thin-shelled, that DDT had this completely unpredictable effect of causing the birds to lay thin-shelled eggs. And that gave a tremendous boost to the whole field of environmental toxicology, and was probably also a factor in the creation of the Environmental Protection Agency. 1972 was ultimately the key year, and that DDT was banned, and the EPA was also formed in that year. Now, fast forwarding to right now, when you're a field biologist, you're the sum total of your life experiences of studying animals and systems. And so I know ospreys very well, and it's always a privilege when I can come back to them and ask a new question. My current studies here at the same site at the mouth of the Connecticut River, the estuary that feeds into Long Island Sound, are food studies where we're using ospreys to monitor the abundance of a keystone ecosystem fish, the migratory menhaden, which is a planktivorous fish of great use to human beings for its key role in the food chain.
Great. Okay, so going back to your involvement with the banning of DDT, what would you say is the most significant threat to osprey survival at this period in time?
Well, the news is good. The osprey has proliferated incredibly after the banning of DDT and proved to be adaptable to a whole variety of systems and very flexible as far as its nest sites go. The birds hit problems in the tropics. They do get shot in places like Haiti, the Dominican Republic, maybe Cuba, and farther south. They have a tendency sometimes to hang out at fish farms. Like all of us, they go for the low-hanging fruit, and they can get shot for their trouble in that situation. So there's still an education job to be done on the wintering and migration grounds in Latin America. And perhaps in some cases there are steps that can be taken to ward them off of those easy-picking fish farms.
Okay.
They're always, I should add, they're always out there as a biomonitor. You know, if some toxic substance winds up in the environment, there's potential that ospreys might be useful in monitoring it. And of course, they're very useful with this positive food story. We have restrained the harvest of the menhaden, which were commercially harvested very heavily farther south down in Virginia, and quotas have been in place for a couple of years now, and we can look at osprey reproduction and also their post-breeding movements and come up with scientific demonstrations of the fact that there are more of those fish surviving now.
Are there any chemicals suspected to be affecting eggs even in a less serious manner than DDT once did?
I don't think there are any firm suspects. I don't think there are any smoking guns. There have been questions of PCBs and dioxin contaminants of PCBs. There have been questions of newer chemicals that do potentially that are slow to decay, just like DDT was. Very stable things in the system. Mostly the story now is a positive one in the sense that we're trying to promote the wise conservation of these fish and leaving more of them in the water as opposed to the anachronistic harvest the so-called reduction fishery, which renders them down into meal and oil, and we need those menhaden in the water, and the ospreys are a great demonstration of that. So mostly this is a positive story about an affirmation of non-human life, I guess you could say. But of course the fish in question are also an affirmation for us because they're so important in the food chain. One of the quotes I use two quotes about all this. The first one is that ecologically speaking, menhaden spins straw into gold. That is, we cast all these nutrients into the coastal ecosystem, and they result in algal blooms, phytoplankton, and the menhaden are filter feeders. They have a unique capacity to take that material up, and then they pass it up the food chain to the predators, things that prey on them, which leads me to my second quote, that bluefish, striped bass, and ospreys are all jewels in the menhaden crown.
How important are menhaden to ospreys? We've seen Steve bringing menhaden to the nest several times a day this past week.
Well, what happens with ospreys feeding the mate and feeding the young, and I should add that virtually all of the feeding, the return of the birds from the tropics at the very end of winter, which is one of the remarkable things about ospreys, they winter down in the tropics, anywhere from the Gulf of Mexico down to the Amazon, and then they come back to secure their mate and their nest site at the very end of winter, and it doesn't look like an attractive proposition to me, but that's natural selection and evolution. That's how you manage to pass your genes on. You come back and secure your nest site. After that, there's going to be a progression of fish coming in either to the estuary. Yeah, let's talk about coastal birds into estuaries and coastal bays. And basically, ospreys catch whatever is easiest to catch. The role division in ospreys, which is also a product of evolution and natural selection, is very strong. Males and females play very different roles in the breeding effort, and the female is larger than the male, and she has a heavier wing loading, and she stays on that nest. She makes the eggs, incubates them, and keeps them warm. While he's the commuter, he ranges around. He has a lighter wing loading. He ranges out to the feeding areas that he finds, and then brings the fish back first to her, and then ultimately to the young.
Okay. Now that we're expecting Rachel and Steve's eggs to pip and hatch in the next few days, another nest in Hellgate, Montana, just lost all 3 eggs to hail. Is it too late in the season for these 2 birds to try again?
Yes, that's very unlikely at this point that they'll try again. Did you say hail?
Hail, yes.
That's fascinating. Those are the vagaries of being a wild creature in an open nest, and it does seem that the breeding cycle is sufficiently long. They have to incubate those eggs for maybe 38 days, sometimes 40, and then you have a period of 7 or 8 weeks before the young fly. That if there's a failure this late in the game, they simply can't do it again this year.
What is the chance of survival of an embryo in the egg if the shell is slightly cracked?
I think very bad. I don't think that works. I've never found in my checks, and I used to check a lot of eggs. It was the thin eggshell was the biomarker of DDT. This was a toxicologist's dream, because when you have a toxic substance, you want to be able to look in the environment for some effect that you can quantify. And it was not until 1967 that thin eggshells were found. I started to get into the field in '68, and then very heavily after that. And I found these eggs collapsing under the incubating birds, and I collected lots of cracked eggs and failing eggs to document and measured the amount of DDT residue in them as well. Other people did that with other species, and that was part of the very large case that was built against DDT. However, I'd like to add a caveat here, which is that environmental stories are often not all or nothing, and DDT was hailed as a wonder chemical, and it remains so. That the huge mistake was the wide broadcast for ecosystem usage in marshes and in agriculture for mosquito control and other pest control. To this day, DDT all over the tropics is used inside houses for mosquito control to try to control the scourges of malaria and dengue fever. So it remains, and it's cheap, and it's very stable. Once you apply it in a house, that application, I'm told, is good for at least a year. And so the worst thing would be to just vilify DDT. It is a very good tool. It's just, as with so many tools in our society, they have to be properly applied to be fully beneficial to human beings.
Okay, so we're going to talk a little more about this nest of eggs hatching. From what day is it likely that the newly hatched chicks will thrive? Is there a golden rule, like 3 hours, 3 days, 3 weeks?
Well, once they're a couple weeks old, they're pretty well likely, unless there's a food issue. Now, the key here, of course, is that they begin incubation with the first egg, and they normally lay 3 eggs is the most common. And so the young hatch in a stepwise fashion. This is a matter of evolution as well. This has evolved over the eons. And the net result is that if there is a food problem, or perhaps the male is an inexperienced one, the smaller young will die rather quickly without harming the larger healthy young. So if there's a food problem, usually that plays out in the first half of the nestling period, let's say in the first 4 weeks. And if there's a climate problem, and there can be, if you get a big northeast storm and the young are very small, let's say they're less than a week old, if the birds are confined in their feeding, or just you have buckets of rain and cold weather, you can lose small young. There is some climate sensitivity there. But notice how massive the nests are, and notice how the male keeps bringing insulating material all through the incubation period. The birds are taking every precaution to make sure that those small young do remain snug and warm once they've hatched. So for every problem, the ospreys they have found solutions. Those solutions don't always work. I'd never heard of a nest being wiped out by hail before, but of course it makes sense.
You briefly mentioned hatching order. I thought you could maybe reiterate for us. Is the first laid egg the first that will hatch?
That's right. About 38 or 39 days. And so if the eggs, if 3 eggs have been laid over 6 or 7 days, you'll see as much as a spread of a week in the hatch of in the size of the young. Sometimes even a little more than that. It seems like some birds get a little casual about incubating that last egg once they have young to feed, or it can be the other way around, that they don't incubate the first egg very much, and so when the young hatch, actually they're closer together. There seems to be variation that way.
Last year, 1 chick hatched within an hour of pipping. What is the maximum time we know for this process to take?
The actual pipping of the egg to the emergence?
Yes.
Well, that's the sort of thing, Osprey Cam is providing us with information that we never had before, because if you drop back, people had to spend arduous hours sitting in blinds to learn these things, and now you can all be citizen scientists from the comfort of your home, and you can even get lazier than that, because a lot of times when something interesting is happening at a nest, like a food transfer, the birds make calls. So if you just leave the tab open on your computer, you can go work on something else, and then when you hear some osprey calling, you just drop back and see what's going on. To answer your question, though, I think typically it might be as much as 24 hours, but I don't have a precise answer to your question. Maybe one of your followers of Osprey Cam will come up with some answers over time. It's probably variable, as to how quickly one gets out of an egg.
Yes, and thank you, viewers, for all of the great notes and citizen science initiative that you take watching the eggs in the nests over all of our cameras. Because there's that great sense of participation. These Osprey cams have caught on like wild. There are a lot of them now. I don't know that there are very few that are as beautiful as that coastal Maine site. Of course, I've been on Muscongas Bay and seen those nests, so I know what a fabulous spot it is. Also, those eggs being that far north are relatively late to hatch. By now, down in Chesapeake Bay, a lot of the young would be anywhere from 1 to 3 weeks old, the Chesapeake being hugely warmer, of course, than Muscongas Bay. And where I am in Connecticut is about in the middle. I'm probably 70% through my hatch here, maybe a little less than that. So, the birds are... they're keyed into ambient temperatures, even though they make this heroic return in the spring or in the very beginning of spring. There are limits to what they can do. I should mention, though, that, and I find this fascinating, I've never heard of a returning osprey dying of exposure, and sometimes they get caught with a late snowstorm. There are osprey biologists and naturalists out prowling around. Nobody's ever found a frozen osprey. So I think there's a couple answers to that. One is that the food, although it's cold, and that's another thing I can't quite relate to, is coming back from the tropics to a diet of cold fish. But it's a high-energy food. And also, if the weather gets bad, they hide away. They go into sheltered coves and things. They won't stay up on the nest for that first couple weeks in that cold end of the winter wind. So... as a friend of mine said of ospreys long ago, and of course this is intended as totally tongue-in-cheek because they're utterly beautiful birds, but a great friend of mine once said to me, Paul, after a couple of beers, they're not as dumb as they look. Let's see. Can Rachel...
That's part of... Let me just jump in again and say that part of the delight of being a field biologist is seeing that fed... and this is not just true of animals, it's true of plants too. A great sweep of salt marsh grass, when you think of the tremendous variation of environmental variation that field of marsh is subject to. Part of the delight of being a naturalist and being a field biologist is understanding the beauty of these systems and how well they work, how evolution has trimmed these plants and animals to be successful out in their ecosystem. And that's not just science, that's art, that was the beauty of Roger Peterson, of course, that he was a fine artist and a great diagnostic man, and he had the science too. But for all of us, that sense of the beauty of the system, if more human beings could connect with that, and ospreys are very helpful that way, I think we'd do much better in our efforts here on the earth. That simple appreciation of the beauty of the earth and what a gift it is to us and continues to be, and how resilient it is in the face of some of the things we do to it.
Okay, let's move on. Is there Can Rachel and Steve hear the chicks moving around or perhaps peeping yet?
Yeah, that's quite possible that they hear them inside the egg. I can't say definitively, but one thing that you will see is that the behavior of the female when those eggs are hatching and with small young, she becomes, it just ratchets up and she becomes very devoted and aggressive. And I've had at least one female that simply wouldn't leave the nest with a small young. I was able to come up with a mirror on a pole, and she just moved over while I was checking the contents of the nest. And I've had other birds, many birds, that were extremely unhappy with me coming to check small young. And then they relax again, most of them, once the young are past that critical period of the first couple weeks or the first week. Again, there's a real, you can sense, I don't know if I want to use the word emotion of the birds. I guess that's a good word to use. Again, that lovely sense of otherness. When you're studying an animal, you have to understand that it's connected to the world in ways that we human beings aren't. And the worst mistake we could make would be to patronize animals for their incompleteness. They move finished because of these evolutionary forces. They see things we never see. Think of the sight of the osprey. They hear things we never hear. They have this annual movement to the tropics in the case of ospreys. And we might look, there's this old expression, free as a bird, but they're not free. They're captive of their own life histories. There are times when ospreys clearly are playful. You get them up on a spring wind, a little thermal, and the birds that aren't committed to staying on the nest will circle around. They'll form a great wheel of ospreys and call back and forth. And, of course, many people who study various animals know when their animals are at play, you might say. Ospreys are good that way.
Can the sounds from within one shell hasten the development of other eggs?
I'm sorry, I missed that.
Can the sounds or the peeps from within one shell hasten the development of the other eggs?
Yeah, well, I don't know if that happens in ospreys. It's pretty clear that that seems to be a generally accepted fact with birds that are so-called precocial that have to get out of there. Things like, wood ducks have to jump out of that cavity and go to water. Grouse have to get off of that nest and follow the female to food and get to a place where they're free of predators. The natural selection pressure would clearly be there with those kinds of birds. I'm not so sure about osprey, given what we all know about the brood size reduction, that there may be no premium whatsoever for their hatching simultaneously.
Is there a period of time during the evolution of an embryo in which it is more likely to die, like during the first 3 months with humans?
I don't really know the answer to that. I'm not a specialist in embryology.
Okay. Let's see if y'all can answer this.
This much I can tell you, though. This is an interesting point. Ospreys have this tremendous commitment to incubating the eggs, and that's hormone-mediated, and probably in turn it's mediated by photoperiod. And once eggs aren't going to hatch, once they're dead, the birds will stay on a little longer, but they won't totally commit themselves to a failed proposition, even if those eggs are sitting in the nest. Now, if you're down in Chesapeake Bay, it's a no-brainer because the sun down there is already brutally hot, and you wouldn't want to stress yourself by over-incubation. What you want to be doing down there at this time, if you're shading young, and they do, the farther south you get in the breeding range, and I haven't mentioned it, but there are loads of breeding ospreys down in Florida that breed much earlier than the birds here. And the terribly important thing becomes, after a successful hatch, can often be protecting the young from the intensity of the sun. And here's the reason. This is a really fascinating. Remember, I've tried to stress the otherness of animals from us. And in the case of birds, think about these young ospreys up on this pedestal in the sun. The only way that they are getting moisture, getting water, is out of their fishy food. There's no water cooler like you and I have for hot weather. The reason they can pull that off, there are two reasons. First of all, they have a gland in their forehead that concentrates hypersaline out of their bloodstream, and it drips off in a little cloudy drop off the tip of their bill. The other thing is that osprey droppings are hyperconcentrated. They're crystalline uric acid. So once again, there's tremendous economy in their water regime. Having said all that, the adults still have to shade the young and protect them because they, even with these tremendous measures of water economy, they simply couldn't stay out in the sun indefinitely when they're small young. Anyhow, when they're large young, of course, they have to until they're actually flying, and then they can go. They can drink regular salt water, and just the adaptations I've mentioned enable them to do that. And if you think about the distribution of birds in general, think about how many seabirds, the Steve Cresses, puffins, etc., are out on oceanic islands where there's no fresh water. I think about the abundance of certain birds in deserts. These two adaptations I've mentioned give birds tremendous advantage, along with their wings, of course, in populating these difficult, these challenging environments of Earth.
So you were saying that some are adapted to drink salt water and be able to filter the salinity?
Oh yeah, they can do it because they've got this desalinating gland in their forehead.
That's great.
You think about all these seabirds out on offshore islands where there's no fresh water. Think of the puffins out on the Egg Rock. There's no way they're going to get a drink of fresh water, and yet they're just fine. You'll see it sometimes with certain seabirds. You can actually see that hypersaline dripping off the tip of their bill with cormorants and albatrosses and such.
Okay, so this is kind of the flip side, or continuing on the last question. When an egg doesn't pip after 42 days, when and how does a parent osprey decide it isn't viable? And when do human experts decide? That's
a very interesting question, and it relates to what I was saying about the hormonal mediation. That I think that after a certain point they just lose broodiness. I think again this is an evolutionary system, and their hormones subside, and they simply lose that incubation instinct. The other thing that sometimes happens is that an egg goes rotten and it actually explodes. I remember that used to happen. I had so many dead eggs back in the DDT era, and I'd put them in the back of my car, wrap them in aluminum foil, and usually I put them in a container. But sometimes I absentmindedly would forget that they were back there. And more than once I had an egg I'd leave my car in a hot place, close it up. More than once I had an egg explode in the back of the car, and that was not a nice experience.
All right. How big of an explosion are we talking here?
A stink bomb.
Oh, God.
Science marches on. What can I say?
Is there any data on the percentages of successful hatches based on the experience of the parents?
It's a very good question. Very good question. And the answer is yes. To some extent, we've had enough young that were color banded with good solid bands such that when they came back we had known age breeders. And there's no question that young birds are less successful in hatching their eggs, and they have other problems too. They put nests in inappropriate sites, so they're more vulnerable to predation, maybe more vulnerable to storms and things. I remember was a classic for me down in Chesapeake Bay, where I've worked a lot, and I lived for much of the year. I had a nest out on a floating channel marker, and that marker rolled around quite a bit when the wake of big ships came by, and yet that osprey sat on top of that. Well, that was the time when and both of those birds had been banded as nestlings, not by me. That was the time in my life when I was doing a lot of trapping of ospreys that had bands on them to investigate this sort of question. And those were both young birds. That was basically an adolescent experiment. So yeah, long-lived animals are on a learning curve, just like we are. Mm-hmm. And when they're early on that learning curve, they make mistakes and they do silly things.
You never really think about that. You think that it's just instinct and that they know, but I guess they would need to learn.
No, there's always that interplay, and that's one of the things that fascinates behavioral biologists. What's the interplay? That's where the term hardwired and softwired comes from. The idea that certain things are so stereotyped and rigid in behavior, that's hardwired, that's in the genes. And then other things are softwired in that they're learned types of things. And these are sources of endless fascination to people who study nature from a behavioral point of view. A great case in point, of course, of what must be hardwired is the monarch butterflies. You know, where that generation that goes south, none of those butterflies have ever been to Mexico before. So obviously, not only is that coded in the genes, but enough has to be coded in the genes to get them to the right part of Mexico, where high enough up where everything works fine for the winter dormancy. And I could go on with countless examples from all kinds of animals. These are the sorts of things that field biologists love to study, to try to pick apart the mysteries of how a particular animal or plant manages to be so successful.
How is that delineated or decided? Studying enough of the populations to see, I guess, how would you put this?
You have let me say, you have sample size and you have multiple sites. You see, ospreys, it's not just me. There's a whole, a tremendous assemblage of people over the years who've been drawn to study ospreys, partly because they're so beautiful and interesting, and also partly because of their wonderful accessibility. The nests are predictable. Every year the birds come back to that same site. Many of the nests are on platforms or offshore duck blinds where you have access. So the osprey has been and remains a bird that's really perfect for field biology and good science, and will continue to be. So it is, in a sense, performing. If we choose to recognize that, it's performing a service for society. It's a perfect graduate student bird. You know, when you're just getting started in scientific research, and you're just getting the hang of it, it's a bird that you can pull these various kinds of data out of.
It appears that all 3 eggs on the Chesapeake Conservancy osprey nest are non-viable. Could you possibly speculate about these reasons why?
I honestly don't know. I have been following that situation, but this much I can tell you. Because of what I've mentioned about broodiness and its mediation by hormones, and the fact that those eggs were laid way back in the middle of April, and the heat of the Chesapeake Bay, I'm very much hoping, desperately hoping, that they're not going to try to put more eggs in that nest, but rather they're going to find a nice, robust little young, with just one young, because we know the male's a young bird, and there may be a problem that way. So my game, if I were there, would be to go find a nice, robust young, about a week, anywhere from maybe a week or even 10 days to 2 weeks old, and I'd pull it out of another nest where there were multiple young in the middle of the afternoon, and once the heat stress of the day was down around 5 or 6 in the evening, I'd put it in the osprey cam nest, and once again, from whatever happens from there, the citizen scientists, literally, I think thousands of people who watch that nest, would be a witness to an experiment. And I can tell you from my own work in my early days, when I moved a lot of young around to test food in these heavily DDT-impacted areas in Connecticut, I brought young in from Maryland as well as eggs, and built up brood sizes to 2 and 3 young, which tests food. I can tell you that ospreys on failing eggs they'll very happily accept a young. That it releases their parental behavior in a hurry. Remember, there would be no shunning, because this is not a species that has to deal with the broods of other ospreys. You know, there's no mechanism there that would cause rejection, and my percentage of success with introduced young was extremely high. Also, another thing I discovered was I could shuffle ages if I had to mix and match. That I could take a nest that had, let's say, 3-week-old young, or even older, 4-week-old young, and if I got a shipment of small young from Maryland, let's say that were a week or 10 days old, and I had to combine them in a single nest, I could drop those birds back to the smaller young, and they just would recapitulate. They'd just raise them up all over again.
Oh.
Yes, this was fun. This was wonderful. You can imagine I was in my early 20s, and to have the privilege of doing this and learn these things, talk about curious naturalists. This is the kind of thing that makes you into a lifelong biologist, when you learn just what you can and can't do in the flexibility of a particular animal.
So this is an intriguing question, and I might have these specifics incorrectly. So viewers, if you ask this question, please correct me. Last year we saw extreme behavior, and I believe this might be some sort of physical abuse from a female osprey at the woodhole nest to the young. How common is behavior like that, and should humans have gotten more involved?
Yeah, I saw that too. Of course, I've been following these osprey cams, and I would say from everything I know, it's very rare behavior, and I don't have an explanation offhand for it. Inevitably, as you go along, when you see something odd, you try to come up with a hypothesis as to why that might happen, so that you have a frame of reference, a way to test. In the future, that's what science is about: is forming tentative explanations. That's what a hypothesis is. So that the next time you get some interesting data, you can see if the hypothesis stands up or you have to modify it. But in that case, I must admit, I'm clueless.
And what percentage of ospreys survive to sexual maturity?
Yes, well, that's a very interesting question. Of course, in that first year of life, when they're naive, they lose a lot. It might be that 60% only make it through the first year of life. After that, we know from return rates and such and banded birds that by the time they become part of the breeding population, at least for a while, they do very well. That 85 or 90% of them come back every year, and that's despite the rigors and uncertainties of migration. I mean, think of all of the things they can hit a hurricane. They have these huge overwater crossings. Rob Beauregard's work documents that so beautifully, his GPS tagging. He's also found some of his GPS tags back in woodlots where ospreys made the mistake on migration of roosting in a place that was the domain of great horned owls, and essentially got eaten as a result. Not much was left but the transmitter. So you have a long period of middle life where the survivorship is good, and then at the end it tapers off again because the birds are getting old and there's no geriatric clinic for ospreys. So the annual survivorship, probably from somewhere around 16 or so, drops off to maybe 75% a year or less than that. And when you trap a banded osprey that's 20 years old, you truly have a rare bird. A few make it into their 20s, but very few. There are lots of birds out there in their teens.
And for what period of time is a female osprey fertile? And I'm not sure if they mean seasonally or throughout their life.
Yeah, well, I don't think there's an answer to the second question. The problem comes that with these really old birds, they've been whittled down so much by mortality that you really don't have a sample size to work with. And as far as fertility goes, we know that that there's this window, given the complexity, the length of the breeding cycle. There's a period of about a month in the spring when those eggs have to be laid if they have a chance of converting into young. And of course, that's very helpful in terms of studying them because you can pretty much predict when your peak egg laying is going to be, and that fits with the other aspects. Another nice thing about ospreys, unlike some small bird like a warbler that completes its reproductive cycle so fast, your osprey study runs from the end of March right into July, and so you can integrate it into your own life. It's a bird that you can very happily live with, and things happen at a pace that we can relate to. That's also true of their individual behavior. Ospreys, like us, spend a lot of time sitting around before they actually commit to doing something, so that makes it easy too. This colony that I'm studying at this lovely marsh island at the mouth of the Connecticut River, Great Island, there are about 20 nests on that island and a few more scattered nearby. So I can sit up on an observation platform near that island, and the odds are that at any given point, males may be delivering food, and if there are points in the day when food is commonly delivered, and there are because these menhaden are schooling fish, and the other male ospreys, when a male osprey scores a menhaden, he comes in, sometimes he displays with it, hovers and screams, and the menhaden shines in his talons. It's obviously a menhaden. It's a very distinctive silhouette. it's kind of like a beehive, and the fact that I can watch 20 nests rather than one is not only desirable from a data point of view, but it's the process that's going on there. This is in fact a functioning colony.
Mm-hmm. You touched on chicks being exposed to the elements, so this is kind of like that. What is the chance of survival for eggs left uncovered or unprotected for hours on end?
Oh, they don't. That doesn't happen. They cover them, but again, Robbie Beauregard had a very interesting idea here, because the incubation period of ospreys is longer than that of the bald eagle. It's on average about 38 days, and that of the bald eagle is about 35 days. The eagle, of course, has larger eggs. And part of the fun of all this osprey stuff is collegiality, that we bounce these questions against one another. And I think Rob had the right answer. He said, well, the eagle has a massive body down, and it can do that because it doesn't hunt by immersion. It just snatches fish and other prey from the surface of the water. While ospreys, both male and female, do full immersion, and they don't have a body down. And his argument was that the efficiency of heat transfer in osprey to the eggs, the simple amount of energy that goes to that developing embryo, was somewhat lower, and that's why the incubation period was so long. I buy that.
How much does an osprey egg weigh? And maybe you can also give us something sizable that we can compare it to.
Yeah, a jumbo chicken egg. Not as big as you might think, because ospreys really, the females are a little over 3 pounds on average, and the males are a bit under 3 pounds, maybe closer to 2.5. And in grams, I forget my gram ounce conversion. The eggs typically weigh anywhere from about 70 grams to maybe 80 grams. And as I said, I'm embarrassed that my brain doesn't have that conversion in it right now. Okay. But I suppose it wouldn't be all that different from a big chicken egg. Jumbo.
That's helpful. Why do osprey eggs have a unique color and patterning?
Oh, yes. Well, it is a very interesting question, and I'm not sure that I'm not sure, because they're not entirely cryptic, It's not like they melt into the nest lining. However, there is a wonderful story about that, of course. Times change and fashions change. Time was over 100 years ago that there was this group of gamesmen characters called oologists who went out and collected wild birds' eggs and made big collections, traded them and such. And osprey eggs were really prized because they're so beautiful and so variable. They run from, a deep mahogany color right up to an ivory color with various spots and streaks, and plenty of them are sort of cinnamon colored with rusty streaks. Sometimes they have lavender spots mixed in with that. So people love to collect osprey eggs. And when the thin shelling thing came up, there were all these dusty old museum cases full of these blown-out osprey eggs, and that proved to be, ironically, the control we needed. We could take our failing eggs, our thin-shelled eggs, and compare them with this pre-DDT material and seal the case. So while I don't, I can't tell you why they're so beautiful. In fact, again, one of these wonderful twists of fate, that nobody saw coming.
Do eagles and ospreys share common nesting and hunting grounds?
Well, they certainly share. Yes, the answer is yes, but there is habitat. Eagles tend to nest, and they often use live trees, and they will nest under a canopy. That is, they might be at the top of a pine, but they might be down a few layers, be it a white pine in the north or a loblolly in the south. Some of them nest in deciduous trees under the canopy, too. The answer seems to be that the eagle's wings are far more robust than those of the osprey. In general, the eagle is a lot tougher customer and can muscle his or her way around the canopy, which isn't to say that they go deep in the canopy, but those long, slender wings of the osprey render it enormously vulnerable to tangling in vegetation. and therefore they like open sites. They really like getting out over water more than eagles like some seclusion on average. Ospreys love being out on channel markers, offshore duck blinds, platforms specially put up for them, and they simply won't tolerate much in the way of vegetation in their flight path in and out of the nest, because that really is potentially lethal to them.
Do eagles prefer vegetation for survival, or just for protection?
Yeah, I don't know if it's protection. Or I think all things considered, eagles they seem to be much more sensitive to human knowledge of where their nest is. They will they'll hide their nest away more than an osprey. Obviously, doesn't hide its nest virtually at all, which has been very useful in terms, again, of population survey. When you go out to figure out how many ospreys you've got in a given area, you can find most of the nest. So this was enormously valuable back in the DDT era, when the birds were just getting whittled down to a tiny fraction of their former numbers, because those few remaining nests weren't all that hard to find.
Are only certain ospreys banded, and what factors does that depend on?
Yeah, a banding study requires a big investment of time and energy, and there's a question of cost-benefit. What are you going to learn by doing it? So typically, usually just one or two really determined people who have a passion for it, and it has been enormously valuable in terms of understanding dispersal, in terms of known age ospreys, so that we can look at the age at which they begin breeding, because that varies. One of the measures of osprey population control. We have this right now both in the Chesapeake and down in Connecticut on Great Island. Nest sites are often limiting, and it may be an extra year, 1, 2, 3 years before a bird that's really potentially a breeder actually gains access to a mate in a nest site. We've learned this through known age birds, through Fish and Wildlife banding and color banding and my retrapping. I did a big Chesapeake study in the 80s in which I found that the mean age at first breeding of those ospreys was 2 years higher than it was in the DDT-depressed breeding of New England. And that's real important, because that's how you get population control. You get mortality in the meantime, and so we don't have ospreys coming out of our ears. So that's fundamental too.
Mm-hmm. How far will an osprey go from the nest to find food?
Well, that's another interesting question, and there's a lot of variables involved, such as the strength of an individual bird, the weather. It seemed like there was a study done in North Carolina where in the spring and summer it was hot enough that there was a lot of rising air thermals, and that scientist found pretty long commutes, and we always thought it was because the birds got a lot of lift off of that warm Carolina lowland. All things being equal, they'll stay as close to home as they can, of course, and that's what we're seeing. This Connecticut River colony sits right next to the food pot, and then there were all kinds of intermediate situations. Seasonally, over in Massachusetts, Alan Poole, and he's worked with Beauregard and has had satellite tags on birds. He finds that early in the season, those birds are taking a lot of migratory alewives, which is another species of herring that comes up into the streams and sits at the base of the streams in the early spring. And he found commutes of, I believe, anywhere up to 10 or 15 miles sometimes to the runs. That's what it's called when the alewives come in to breed, to the runs where the alewives were moving.
Is there a correlation between outside temperature and hatching time?
Not that I know of. Oh, well, I mean, there's a latitudinal correlation, to be sure. Everything happens earlier as you go south. That's straight thermoregulation. Mm-hmm. And another point that way is that within any given area, the more exposed breeding sites are the later to lay and the later to hatch. Between New York and Boston, the latest hatch comes out on Gardiner's Island, New York, because it's thrust way out off of Long Island, surrounded by, water is very slow to warm up. and so it's like living in a little bit of a refrigerator. Down in Chesapeake, the same is true. The last ospreys to nest are out on Smith Island, Maryland, which sits way out in the middle of the bay, surrounded by bay water that's slow to warm up. The first ospreys to nest in the Chesapeake are the ones way up the big tidal rivers, many miles up, where essentially they're in a continental climate. And the difference is almost a month. You'll get your first eggs right about the 1st of April up those rivers, and Smith Island isn't laying until the 3rd and 4th weeks of April. So that once again, the birds are very much shaped by ambient conditions.
Mm-hmm. Well, now that we see the benefits of having a number of live cams on osprey nests for all the great data that we might not have been able to capture previously, does that now give us a responsibility to intervene, like what we saw in the Woods Hole last year's situation?
Well, I'd say that's natural behavior. I would intervene immediately down there in the Chesapeake on that Chesapeake Conservancy osprey cam, simply for reasons of human education. It does no harm to remove one young from a nest somewhere around there. There's so many nests on the eastern shore. So many people watch that, and so much human investment has been made in that cam. I'd be out there tomorrow if I weren't in Connecticut, taking a young from a nest and putting it in there on those instead of those failing eggs. I'd just leave maybe one of the eggs there for familiarity's sake, because they might settle in again. But it'll be a lot of fun if they do that, just to watch, for everyone to participate in that little experiment. So, and I obviously would love to see that cam remain active for the rest of the season, rather than going offline when those eggs, Oh, there was one wonderful thing. I've loved these osprey cams because, of course, they've opened my eyes to some things. Didn't want to forget this. Of course, initially these young are helpless, and they can beg food and not much else. And it's very interesting over their 8-week development, 7 to 8 week development. First of all, for the first week or 10 days, they don't know that I'm not an osprey. So if I go up to the nest, they beg food from me, and that's sort of fun. And even if I'm just holding a mirror over the nest, if I'm on the ground with a mirror on a pole, just that presence of the mirror, they start to beg food from that object. And then, about halfway through, 3.5 weeks, they really start to resemble ospreys a bit. And they start to take a role in the maintenance of the nest. That is, they will put the sticks that the adults bring, they will pile them up and make a perimeter around the nest so that they don't fall out. Because, of course, they're goners if they should get blown out of that nest or fall out of it. And I've watched on osprey cam these half-grown ospreys. They have coordination of their bills and their necks and their bodies. They very carefully place those sticks around the perimeter of the nest. They get another benefit from this, which is, again, I mentioned the moisture stress thing. One of the things they can do to stay cool, they don't perspire like us, but they do, they pant, just like a dog. A dog can't perspire either. They flutter the tissues of their mouth and their throat to get some evaporative cooling. Apparently that much water they can afford to lose. And that works best if their heads are up high out in the breeze. It doesn't work so well if they're down in that nest. So by piling those sticks, they elevate the edge of the nest. And then in that hot Chesapeake weather, they'll get over there at the edge of the nest and hang their head up on those sticks so they get maximum cooling, and the rest of their body a bit too. But at the same time, they've created a perimeter such that they're not going to fall out or get blown out. And I just thought that, I never figured that out before the osprey cam, that whole scenario that I've just laid out for you. And of course, it's always, you get to know an animal, and then you just get to know it better and better, and all of a sudden one day, a new technique comes up, and you learn something that you maybe hadn't even dreamed of. So that's a wonderful thing about the osprey cam.
So there's still surprises for a decades-long expert like you.
Yeah, there sure are.
Do you travel to study ospreys?
Oh, yes. I have a study going with my colleague Alan Poole down in Belize. Belize is intensely interesting because It's the end of the line for ospreys in our hemisphere. They do not breed south of Belize. That's about between 16 and 18 degrees latitude. And things are very different down there. They're never at high density down there. They're sparse. They don't produce very many young. Of course, they're breeding very early in the season. They're laying their eggs mostly, not all, but mostly in December and January. We go down in February to check the situation out, and we find a variety. We find young, mostly older young, but there's still some birds that are close on smaller young and possibly even eggs. We haven't been climbing down there for various reasons. We haven't had very many nests that we're still brooding. Those are non-migratory ospreys. They don't produce very many young. We think the reason they can be stable is that they don't suffer that migration mortality. We also think they breed younger, quite a bit younger on average, because they never leave the breeding habitat, and so they're familiar with it at a level that takes the migratory birds a little longer to, actually quite a bit longer potentially, to connect with the resource at a level that they can supply the nest. So this is that Belize study, which we intend to continue, because there aren't that many. We don't know. We think we're maybe the total coast of Belize. Belize is about as long as perhaps, maybe Vermont, and the total coast. We may have 75 nests there. We may have only 50. We're really not sure yet, because we're just we've only done a couple of years, and it's expensive, and there's a lot of logistics involved in finding these relatively rare nests. None of them are along the mainland coast. They're all out on mangrove and coralline islands, sort of in the middle of the huge bays of Belize. Just a few of them are out along the barrier reef. It's fascinating.
Great. Well, it looks like we're coming up to the end of our hour, and I and Explorer Audubon and our viewers would really like to thank you for participating and giving us so much knowledge that we didn't have before the hour began. Is there anything, any closing remarks you'd like to make?
Well, first of all, Rick, I'd like to thank you and your viewers for the great set of questions, and also for your ability to pick my brains. I feel like you've really picked them quite thoroughly, just as thoroughly as an osprey eats a menhaden.
Great. I'm glad you had a good time.
Thank you.
Okay, well, great. We will. We hope to hear from you again soon, and we'll keep in touch. And Rick, you should ask me about loons sometime. I've worked for, what would it be, over 25 years on the migration and winter biology of the common loon, which is not very well known. Everybody studies them up on those main ponds, but there's a tremendous amount of loons are amazing animals in their own way, just as amazing as ospreys, and they do it in that tremendous body, which has some very great strengths but some great weaknesses. So maybe sometime we should talk about loons. Absolutely, yes. Anything that you're interested in, I am open to listening.
Okay.
All right, thank you so much.
Take care.